Hello everyone. This is our computer networks presentation. We are going to be going over our network analysis over the game REPO, and our team is named Wingrar. This is the table of contents for our presentation. Our project goal is to focus on monitoring, capturing, and analyzing the internet traffic generated by REPO during various gameplay scenarios. We aim to gain insights into how REPO communicates online, identify potential security or performance issues, and better to understand the underlying network protocols used during gameplay. This is our project team. My name is Abigail Avila, and I'm the project manager.
I'm Russell Sines. I'm a project researcher.
My name is Reynaldo Gonzalez, and I'm the project analyst.
My name's Gabriel Maisonet, and I'm a project researcher.
Our game application is called REPO, and it is a co-op survival horror game. It was released for early access on February 26, 2025. We chose it due to its immense popularity and affordable price. It also has simple yet fun game design.
All right, so one of the first things we did when starting this research was figure out how to keep our data as clean and accurate as possible. Even though in-game voice chat is a big part of most online games, we realized early on that it could interfere with the network traffic we actually wanted to analyze. Voice chat creates its own stream of data, and mixing that in would have made it harder to focus on the gameplay related traffic. To avoid that, we took a few precautions. We closed all non essential apps, used our phones for team communication, and recorded each session with OBS. That way, we had more controlled setup and could trust the data we were collecting. As we played, we kept track of important in game events like loading into new areas or interacting with online features and marked down the exact times they happened. Later on, we used those timestamps to match up with the internet protocols that were active at those moments. This helped us clearly see how different types of data were being handled during actual gameplay and gave us a better understanding of the network behavior behind the scenes. Next slide, please.
This slide shows the main protocols used in game networking. First, we have UDP, User Datagram Protocol. It's commonly used in games because it's fast and lightweight. It doesn't wait for acknowledgments, so it's great for real-time actions like player movement, where speed matters more than reliability. For Repo, since it's a horror game, you'll have monsters coming after you and you have to try to avoid them. Therefore, UDP is very important since you don't want to be just grabbed by a monster even though you've already ran away from it on your screen. Next, we have TCP, Transmission Control Protocol. This one is reliable and ensures data arrives in order, which is ideal for things like downloading maps or syncing large game files. This is important since Repo's maps are procedurally generated, so it needs a fast and reliable protocol to be able to sync the maps between the players and overall ensure that the maps are properly downloaded. Lastly is TLS, Transport Layer Security. This is a protocol used to encrypt large data over the network, often layered on top of TCP. It's important for protecting things like login information or sensitive user data. Since Repo is a multiplayer game, it is very important that you have this layer. You need that security so that others can't access your information. All of these protocols work at or above the transport layer of the OSI model. UDP and TCP handle the actual data transport, while TLS adds security on top of that, ensuring encrypted communication between client and server. Next slide, please. In our research on the game Repo, we discovered that the game uses different protocols for different tasks. Most in-game actions like player positioning and interactions are handled with UDP, which makes sense because the actions need to be fast and responsive even if a few packets get dropped. On the other hand, when the game is loading into maps, it uses TCP. It's because these processes need to be reliable and complete. It's okay if they take longer, but they need to be accurate. This split between UDP and TCP is very common among multiplayer games. It lets developers get the best of both worlds. Low latency for gameplay and reliability for setup or background operations like maps. Next slide, please.
Game interactions and network packet exchanges. A mixture of TCP and TLS protocols are employed to handle critical in-game events, such as player deaths and purchases from the in-game store. These actions require absolutely no dropped or duplicated data, making lossless and ordered communication essential. In the capture below, you can see a sequence of packets relating to a player's death. Whenever whenever a lossless action takes place, then the server makes connection with TLS and sends ordered packets using TCP. While UDP is commonly used in games for fast real-time updates, TCP is needed for its lossless uh, properties. Next slide.
So, tracking internet protocols during gameplay was both challenging and rewarding. We expected some complexity going in, but the reality was more intense. At times, the data traffic was overwhelming with high volumes and unpredictable bursts of activity. Other times, it felt underwhelming as it was difficult to find consistent patterns tied to specific in game events. Still, those challenges pushed us to dig deeper. Over time, we developed a clear understanding of how different internet protocols function, what roles they serve in online gameplay, and how they respond to various triggers and conditions within the game environment. We also learned to pay close attention to context, not just what data was moving across the network, but why it was happening at a particular moment. This gave us better insight into how games manage their online infrastructure. Just as important was the teamwork behind the project. Our group maintained strong, honest communication throughout. Tasks were clearly divided, roles were respected, and we adapted to changes in schedule with flexibility and transparency. That consistent collaboration made a big difference. It kept the project moving forward, even when the technical side became difficult, and played a key role in the success of our research. Next slide, please.
Lessons learned. Games communicate using a variety of methods, often allowing for some packet loss to prioritize speed. But they deliberately use lossless protocols to ensure that crucial actions are preserved without errors. Selecting the correct protocol is key. TCP, which ensures reliable data delivery, UDP for fast real-time actions, and TLS for secure communications. Balancing performance and security is imperative. Next slide. Thank you all for listening to our presentation, and I hope you have a good day.